Challenge activity 8.2.4, an online retailer has a new website and would like to compare the proportion of customers who made a purchase from the old website versus the proportion who made a purchase from the new website to see if the two proportions are different. That tells us we're looking at a two-tailed test. A simple random sample of customers visiting the old and new websites is taken. The results are shown below. So let's go ahead and find our number. Oh, I keep hitting the arrow and it keeps giving me that number. Okay, so first we're going to find our p-value. P-value right here is 0.069. We need to find our z-score. So remember, if it's given here in the positive, then we need to put the negative on this side. So here's our negative 1.819, and here's our positive 1.819. Negative 1.819, positive 1.819. Because remember, when we're looking at a two-tailed test, we're trying to find this area on both sides and add it together. So that p-value is going to be the sum of those two areas. Old site samples N1, we have 400. New site samples N2, we have 100. Sample proportion, p hat 1 is going to be 0.39, and p hat 2 is going to be 0.49. So check our answer, green check mark, that's always a good sign. Two substance abuse clinics would like to compare retention rates for the programs offered by each to see whether the proportion of clients who stayed in after 90 days is different for the two clinics. A simple random sample of clients from each clinic is taken, recording whether the client was still in the program after 90 days. Clinic B has more clients and was able to collect a larger sample. The results of the sample are shown below. What are the population parameters? Very similar options as we've seen throughout this section. We're not looking at sample size or means, and here it says the sample right here. So we're looking at the proportion of all clients for each clinic that remained in the program after 90 days. It's important to remember, and I've noted this before, but I want to make sure it's clear, we're using these samples to test hypotheses about a larger population. Like if we were just concerned with the samples, we wouldn't need to run a hypothesis test, or if we had the full population of data, we would just compare those numbers and we wouldn't need to do a hypothesis test. But the idea is that we just have a sample that represents a larger population, and we're using that sample to test a hypothesis about the larger population. All right. The level of significance, here's our confidence level of 99%. This means our alpha, or significance level, is 0.01. The null hypothesis is that P1 is equal to P2. And here it said that we are testing to see if they're different. So even though up here we're told it's a two-tailed test, we can also see when it says is different, instead of saying less than, greater than, or some other verbiage about like similar to that. We know that we're doing a two-tailed test where the alternative hypothesis is P1 does not equal P2. Our p-value here is 0.246, which is clearly larger than our alpha of 0.01. So when p-value is greater than or equal to alpha, we fail to reject H0, and we would say that insufficient evidence exists to support the claim that the retention rates for the two clinics are different. Let's check. Nice little green check mark. All right, that is challenge activity 8.2.4. Let me know if you have any questions.